Hello everyone. I've repaired perhaps a couple of hundred of these boards. It's a JBL 515 power supply, although this section here, which is a half bridge power supply, is pretty much identical on all of them, all the JBL range that use the switch mode power supply. And you know, I see them blown up and I see FETs blown and they come in and I think, well, okay, that's the standard fault, and you can see that on the other videos, the repairing of these faults. But lately I've been getting failures of a different kind. There is a version of this. Most of the ones, probably 90% of the ones I've seen at least, have a relay in here, then a flip-flop and a comparator to control the 110 220 volt voltage doubler circuit, which closes this relay and doubles the actual voltage to run from 120 volts instead of 240. Now this one was all fixed, it was all done the parametric test, and I did one last final plug-in and bang, it exploded. And this had happened to me once before. Actually, thinking about it, it's the only time it's happened to me before, was with the same design, i.e. the non-universal version of this with a stripped down electronics. So they stripped all these components out down here, and this will now only run, they've taken this relay out, and it will now only run from 240. Now there seems to be a reliability issue with this particular design. It's particularly bad. I'm not saying the others are actually foolproof, but they are particularly bad. And the problem is, I think, probably, I'm just going to investigate this in a moment, but these are really designed to run for 220, 230. And if I look at my mains voltage now, it's straight out the mains socket. If I just turn it on, it's not making contact. Just wiggle the probes around. There you go. I've got 268 volts AC coming out of my mains, and that's on a kind of overcast day. And there's a lot of people with solar PV around here, and as the solar PV starts to get sunshine on it, the voltage goes up, and I've seen this voltage here at my house up to 278 volts. Just a reminder, the spec for the UK mains is 230 plus 6 minus 10, so that gives you between 215 and 245. But at the moment it's hovering around. You see it's varying slightly, going all over the place, but if the sun comes out in a moment, it's kind of bright but not full sunshine, you'll see this go up, and it's to do with all the solar PV around here and the poor impedance of the mains, because we're on cables that go down the road. And we're at the beginning of the cable, so they bump the taps up at the substation to give the people at the end, after it's been down half a mile of cable, 220, 230 volts. And in fact, I've got a friend who lives down the road who's at the end of the cable. When you turn the kettle on, you can actually see the lights dim slightly. So to do with the integrity of the supply, I could complain. I have it on good authority that complaining will get you nowhere if your mains is too high. But that's what I'm got at the moment. I've got 268. I trust this meter. I've tested it. It's not calibrated, but I have checked it against a very accurate signal generator, my high voltage supply. So yeah, so that's the mains we've got at the moment. And as I say, I've seen it up to 275, 276 volts before, RMS. Frequency's good though. So yeah, so that's that. So we've got a voltage issue, and the problem that I've seen is that when I connect the power, I do it on my clean supply. I test everything, and I've got a clean, regulated, true sine wave supply to do the testing with, so that you can get a standard reading of the current consumption, the power factor and everything else, so I can see that the power supply is working properly. And I just plugged it into the mains to do the check, the parametric check on the audio analyzer load circuit setup that we have, and it just went bang. And that's happened to a couple of these, and I think I found out why actually. So I'm just going to investigate this, and the key issue actually that I've been looking at the circuit and trying to work out what does what is that there's no soft start on this. There's only a power supply voltage sensor, which is the B plus voltage from these two capacitors, goes through these two resistors down to this resistor here in parallel with the capacitor, and that signal goes off to one of the input comparators on there, which is comparing it to the 5-volt rail from the chip. This chip has got an internal 5-volt generator. I'll show you on the schematic in a minute. And when the B plus goes above a certain voltage, it just turns it on, and away you go. So if the 5-volt for the chip comes on and the B plus is still high, then this is going at full no dead time, just full power. Turn the FETs on maximum whack to get this capacitor to charge up really fast. And these always invariably these always fail at startup. I've spoken to enough customers and say, well, it was working when I put it away, and I put it back on, not working. You know, next gig, plug it in, no sound, no blue light. And I know that from a fact, because these two that have failed on me over the years have always failed at switch on, after they've been running perfectly fine in the heat soak and everything else, and everything looks fine. And I'm pretty confident it's not the quality of the components or anything else I've put on, because usually all the semiconductors on here, all the semiconductors have already been changed once. And I had this on a previous one, which I'd finished it and it blew up. So I know them well enough to know that there is a design fault, and at 240 volts they go bang when you get the catastrophic failure mode, i.e. the FET's blowing up in the power supply side. It's when you turn on. So I'm going to have a look at, there is a dead time delay pin, or a dead time setting pin on here, which you can use to actually reduce the increase, which you can use to increase the dead time between pulses to the power supply. So it's still running at the fundamental frequency, but there is a dead time which will effectively reduce the power output of these FETs and protect them during startup. So I'm going to apply a mod to this, change all the semiconductors again, and then hit it with the supply a lot of times to see if I can blow it up afterwards. So that's the problem with these. They blow up on switch on, and especially this kind that haven't got this relay fitted, or this electronics around here. It seems to exacerbate the problem that's already there. And of course, as I say, the problem is they were designed for 220 volts. So on the continent, you'll be fine, but over in the good old UK with up to 200 and what we had 78 volts, we can it's too much for them when you turn on. And it seems worse, more likely to fail when you've just disconnected the power and then you plug it back in. So if you do a quick, like, whip the plug out there and put it in there, it goes bang. If you just plug it in, it comes up okay. So it's something to do with these already being charged. Maybe, I think I calculated the cutoff voltage with the circuitry, and yeah, if the voltage on these drops below 260 in this arrangement, then the chip is disabled via this resistor chain, but there is some time constants in there. So it sounds like when you first plug it in, and this capacitor is completely flat, and these are partially charged, my conjecture is, not unproven at the moment, but conjecture is that there's too much current flowing in the FETs, and we could do with a soft start to bring it up a bit more slowly and be kinder to these transistors. And since they generally fail at startup, it seems like a reasonable conjecture at the moment, not proven. I could mess about. The trouble is that every time I blow them up, I have to change all these components. So what I might do is leave the FETs out, build the circuit back up, and then adjust the dead time accordingly to make sure it works, and then put the FETs in and try it. So I think I might do that actually. But when I've done it, I'll show you what I've done, and I'll show you the results, and hopefully we can get these things reliable. But as I say, if you see one of these and it's got that relay missing, you're sort of wasting your time repairing it, because as soon as you plug it in to an unclean supply or an over voltage supply, or there's a bad connection on the mains lead, you're back at square one. Alright, so let's get on with that, and I'll come back to you. Well, I've been checking the startup of this thing, and it's not straightforward. And the trouble is, you've got two very large reservoir capacitors here which discharge slowly, and there's a separate DC supply underneath there which provides 15 volts for this circuitry. There is no soft start. All there is a cut-off, which when the voltage on the input goes to about 190 AC, it inhibits the SMPS management chip, this one, from driving the FETs. But there is no soft start. But the problem is, implementing a soft start is not be that straightforward, because the relationship between the 15 volt line and the 5 volt line and the mains going on and off is a problem, and there is no current detection on the output driver stage, so there is no cycle by cycle protection of these FETs. As the thing powers up, it just goes full chat. It's either on or off. It doesn't start slowly. And because it's a half bridge, I can't easily see where I can put a current sensing circuit in to sense the current in the primary. What it should do is that when you switch the FETs on and the current peaks in the FET, you should back the FET off or switch the FET off before it overcurrents. It happens in microseconds to prevent the junction of the FET being blown up, and that's why they're blowing up, I think. So it's going to require a bit more thought onto this. I thought it was going to be a simple modification, but to get it to work properly, going to need quite a lot of extra circuitry. I can't think of a quick fix for this. It's tricky. I can see what's wrong now. I can see what's happening, but I've got to find a way to, when the mains dips and the output capacitor over here, this one, is discharged, we want these to start up in a soft fashion, not go full chat straight off into a discharge capacitor. Yeah, how to make it reliable. Back to the drawing board, back later. Right, it's 2 days later. Over the last couple of days I've probably spent 4 or 5 hours on this, and you can see I have lashed on a modification. It's a mess at the moment. I've got things sitting on top of the chip. I've got wires and resistors standing up a tombstone. I actually reutilised the pads that the LM393 were on because I'd left it off. So what's the difference with this between this and a standard JBL 515? Well, what have we got? First thing is that the startup conditions are no longer chaotic. I'm arbitrating the various voltages, like the B plus voltage from the big capacitors, the high voltage line, the 5 volt and the 15 volt lines, until they're all in a stable condition, and then I allow the thing to power up. The unit doesn't do that at the moment. If you get a dip, then it's undefined. The second thing is that it can't go into a chaotic mode during power down like it could before. But mostly these blow up. I've done enough of these to know that they blow up when you switch them on, and I've implemented a 75 clock cycle slow ramp up on the power supply chip. So when you turn the power on, the capacitors charge up. When you reach a threshold, instead of coming on full chat, we increase the power through the power transistors over 75 clock cycles, and what that does is just to limit the maximum current in the devices. And if you look on the online debugging and fixing issued by JBL, how to repair one of these things, it's very sketchy, but it says they've had trouble with the power transistors blowing up on power up. Okay, so I could blow this up at will with I've got a clean power supply, and I can cycle the power up and down under program control, and I can blow these up at will, and I've proved it before. But this one doesn't. This one, when it gets above a certain voltage of the mains, i.e. if the mains input goes too high, you get a surge, this switches off the actual power transistors before it gets dangerous. And then when the surge is gone, it comes back. I thought about, well, how can you, if you're on a gig and you get a power surge, well, you're going to have a short cutout on your speakers as someone unplugs some lights and the generator goes up, or whatever happens, causes a surge to 270 to 80 volts, which will destroy your unit. This will switch off the switching power supply, turns off as the voltage starts to rise to a dangerous level, and when it drops back down to an acceptable level, it turns back on. Alright, so 3 levels of protection really are built into it. Now, I'm not sure, I've only seen perhaps 10 of these power supplies. The The I don't know if you could tell what they are. This is turned on. I have to be a bit careful here. Yeah, so on the back of the unit, you'll know you've got one of these units because on the back label under here, under this part where all the mains input socket is, next to there on the label it says 220 to 230 volts input, right? Say 220 to 230. Yeah, it says 220 to 240 on the label on the back, so it's not a dual input one. The other ones are 110 to 240. In fact, my mains is what my mains is at the moment. Yesterday with the sun out it was 278, so it goes crazy, especially with solar PV everywhere. As I mentioned, the input from all the different areas of the local generation are starting to lift the grid, and I don't know what they're going to do about it actually, because all the transformers are all wound and designed for a load basis, so everything is taking a load. But now people are feeding power back in. It's going crazy as far as I can see. At my house I get 278 volts sometimes, and that's when I blew this up, when I plugged it into the mains and bang, and I thought what the hell's going on. Looked at the voltage, 270 volts on the mains. This hasn't got the margin built into this product. There isn't the safety margin built in this product to work off a higher voltage. That's why I put the cutout when it goes above 270. 265 actually, and you know most places won't do that, but they could surge above that in exceptional circumstances, and then boom, your speaker's gone. Anyway, so this is the rat's nest I put on at the moment. You can see it is a complete rat's nest, but it involved lifting all the pins and intercepting all the signals. Now what I could do, and I don't know whether I want to do this or not, it depends if anybody else wants to. I'm not looking for profit, but there will be some costs associated with getting the board tooled up. But I could make a PCB, which when you lift off this chip here, the main power supply switching chip, and you solder on a header on its pads, a vertical pin header, then the modification board will plug on the top of there. And I don't need any other connections because the comparator, the transistor, and the two comparators, the chip and the conditioning for the startup components will all be on this small rectangular board, which just plugs onto there. And then you put a dab of silicon there and a dab of silicon there, push it down, and that's the modification. Now I could tool that up if you've got an issue with reliability, and this circuit is the same on the JBL 315s, the JBL 500s. They've all got the same issue actually. That's why in this country they don't have a great reputation for reliability, but if you go to America they love them because they were designed to work on 110, not rogue 240. So yeah, if you're interested then get in touch, leave a comment below, and I'll quickly engineer up a small daughter board to go on here to modify these power supplies to make them reliable, robust as they say. But you can see it was frustration. I kept adding bits on another function, and I ended up with the right hash of wires and components all over. And I've reused some of the empty component pads down here. But if you've got one of these, then you might want to consider having it modified if you've got problems with reliability, because as I say, I've blown up two recently just testing them, and they are clearly not as reliable as the dual voltage ones, the ones at Universal that have this relay for switching the voltage doubler. They're not without their problems, but these seem worse. So check on the back label. If you've got 220 volt only, then this could be useful. Also, actually this modification would fit okay on a standard 110 to 230 universal input unit. It would work on that as well. It's not actually limited, it's working on the actual voltage across these capacitors and the switch on and the relation to this 15 volt supply from here, which is an independent supply, and then overcurrent and then slow ramp startup. And the current in the FETs goes down from like 60 amps peak down to about 31 amps peak with the startup. So the startup, I've had the current probe in there, and it does make a big difference to the peak current on the actual FET drain source. And it's these that explode. It's just this one usually gives up when you power up, that one there, then cause a catastrophic failure, The 300 volts from here gets into the gate drive circuit, then it goes down the gate drive circuit, destroys and explodes all these components here, and then takes out all the other semiconductors, certainly the chips, on the drive circuit. And I noticed another problem which I've never seen before on here. They seem to have put a 75 ohm resistor down here feeding the 7380 half gate bridge driver circuit. There's a series resistor in the power line, and it had blown on this one when it blew up, and I put it back together and it doesn't work. I thought, what's going on there? And actually this resistor up here, the 75 ohm one, was about 200 ohms. It was almost blown open, and there was no drive coming out there. But if in doubt, you want to make this work, then take the FETs out, then you can power it up and have a look around, provided you've got an isolated supply. You can't do it on normal mains, alright? So if you're interested in getting this engineered so that you can upgrade your units, then click to the box down there. If I can get enough people that want to contribute a small amount, I'm talking about £10 or something like that, I'll go off and get the board made, and then we can engineer a solution for it. But I hope you like that, and if there's one of these and it's blowing up, don't throw it away, just get it modified.